Okay, so we're talking about partial fractions, and if you take calculus, you will see these again. So we're just going to touch on them, on some of the main things, and I've just got to plug up my headphones. They're running out of battery, so let me just pause for a second here. Okay, so our first problem is 20. So let me get to that. So the whole idea behind partial fractions is to take a rational expression where the denominator is factorable and write it in terms of the factors. So if we were to factor the denominator, so you'd have x plus 3 and x minus 2. What numbers multiplied together give you 6, 2 and 3, 1 and 6. The difference between the two, or the sum of them, in this case it's going to be the difference. And we use plus 3 because that'll give us a plus x here. So what the idea is to take this form and make it into two simpler fractions. And this will be useful in calculus because we're always trying to manipulate the equations so that they are solvable. And this is not solvable, but those are solvable. Okay, so what you do is you need to combine these two terms by finding a common denominator. So the common denominator is always the product of the two. So to get that, I need to multiply by x minus 2 in the denominator, but to make it so that I'm not changing the value of the expression, I multiply by x minus 2 in the numerator. And you do the same thing here. You're going to multiply and divide by x plus 3. So now we have the same denominator in both sides. So you can combine those two and you get a times x minus 2 plus b times x plus 3, all divided by that. And on the left-hand side, you got this. So now you can just set the numerators equal to each other because the denominators are equal to each other. And the idea is you've got to figure out what a and b are to make this work. And when you have what we would call distinct linear factors, you can do it by judiciously choosing two x values. And the x values are always the zeros associated with these factors. So we're going to let x equals 2, which is the corresponding 0, and x is equals negative 3. So the reason you do that is so when you choose those, one of the constants is multiplied by 0, and all you're left with is the second constant. So we plug in 2 here and 2 there. This one goes to 0. So you get 5 is equal to 5b, because we have 2 plus 3 is 5. And you solve for b, it's 1. And over here, you have 5 is equal to a times negative 3 minus 2. So we're plugging in for x, we're plugging in negative 3, and that makes it so the second term goes to 0, and we're left with the first one. So you get 5 is equal to negative 5a, or a is equal to negative 1. And so we substitute those back in here, and so the original rational expression is going to be equal to negative 1 over x plus 3 plus 1 over x minus 2. That's equal to 5 divided by x squared plus x minus 6. And what they're saying is prove this is correct. So you do that by saying, okay, well, I need to find a common denominator. So I'm going to multiply by x minus 2 and divide by x minus 2, and then you got the second term, which is plus 1 over x minus 2 times x plus 3 times x plus 3. And in the numerators we're going to have negative 1 times x, which is negative x, negative 1 times negative 2, which is positive 2. And here we're just going to have 1 times that, so you get plus x and 3. And we're going to divide that by x minus 3 times x plus 3 times x minus 2. And if we use FOIL, we'll get x squared plus x minus 6. And then these cancel out, and these combine, and you get 5 divided by x squared plus x minus 6. So that's proving that we did it correct. Okay, next one, similar kind of thing. We've got 3x divided by x minus 3 squared. So in this case, because we have a repeat linear factor, our first one is the factor. The second one is the factor squared. So we do the same thing, except this is the only one that we're going to have to do anything with to get a common denominator, because the second term already has the common denominator. And again, what's happening here is you might say, well, I've got something squared here, got something squared there, so what's happening here? Well, you get rid of the x term. So that's important. Okay, so we multiply it by x minus 3 and divide by x minus 3. The second one we don't have to do anything. So then we multiply it out, combine the two terms in the numerator. So you get x minus 3 squared. So now that we have a common denominator, we can set the numerators equal to each other. Now this one's different in that you've only got one choice that's obvious. X is equal to 3. That'll make that go to 0. So what you get is 3 here. This 3 times x3 is equal to a times 3 minus 3 plus b. So that goes to 0. You'll get 9 is equal to b. B is equal to 9. And the second case, x equals 0. It's always a good choice, because that makes this go to 0. So you get 3 times 0 is equal to a times 0 minus 3 plus b, but we know b from the previous step. So you get 0 is equal to negative 3a plus 9. Get negative 9 is equal to negative 3a. A is equal to positive 3. So those are the two values. So this original thing, 3x over x minus 3 squared, is going to be a, which is 3 divided by x minus 3, plugging it in up here, plus 9 divided by x minus 3 squared. So that's the answer, and they want us to prove that it's true. So you take 3 divided by x minus 3, multiplied by x minus 3, and divide by x minus 3 to get a common denominator with the second term. So what we'll get is 3x minus 9 plus 9, all divided by x minus 3 squared. See, the 9's cancel out, and you're left with 3x over x minus 3 squared, and that's what we have initially. Okay, 29. So this next one is an example of a linear factor and a quadratic factor. So you can't factor this one because there are no real zeros. The answer would be plus or minus I. If you did it, you complex result. So when you have a linear factor, you take the constant a and divide by that linear factor. And then as far as the quadratic factor, you take bx plus c. So that's how we want to break it up. Again, we're able to solve these in using calculus. This one's a simple. This is simple to do when we need to do what we need. I can't explain what we're going to do to it because you haven't taken calculus yet. But anyway, these are not solvable. This is solvable. Whatever that means. Got to take calculus to figure that out. Okay, so we do the same thing we did in the first one. We're going to find a common denominator, which is going to be the product of the two individual denominators, which is the same as the denominator over here. So we take a over x and multiply it by x plus 1 squared, x squared plus 1. Now the second part, we need to multiply by x because I've got x squared plus 1 in the denominator, so I need x to make it the same. And on the left-hand side, you've got x squared minus 1 times x squared there. Okay. Now you combine the two fractions on the right, so you get a times x squared plus 1 plus bx plus c times x, all divided by x times x squared plus 1. So just like in the previous ones, we now have the same denominator on the left and right hand side. So you set the numerators equal to each other and then figure out what a and b and c need to be in this case to make this thing work out. Now, you do it differently than when you have linear factors. So what you're going to do is one thing is I'm going to put in a 0x because we need to show that explicitly. You don't need to show it explicitly, but I'm showing it explicitly. So when we do this, it'll all make sense. So I put a 0x in there. So I've got 1x squared plus 0x minus 1. And on the right-hand side, I just distribute everything. So a times x squared, a times 1, you get that. Bx times x is bx squared, and c times x is cx. And then you group the terms together that have the same last part. So we got two that have x squareds. We just have one that has a linear term in this case, and one that has just a constant. And then you break this one equation up into three separate smaller equations. For this to work, the coefficient in front of x squared has to be the same coefficient in front of x squared on the other side. So on this side, the coefficient's 1, and on the right-hand side, it's a plus b. As far as the x term, there's 0 on the left, there's 1 term on the right, and then you have the constant, which is -1 on the left, and a on the right. So from this one, well, actually we don't need an x, we just need c, because we have 0x and cx. So 0 equals c, or c equals 0, so that's one thing. Secondly is a is equal to -1, that's the second thing. And then you could solve the last one. If you plug a in that you get from this into there, you'll get b is equal to 2. So that's the answer. So it's going to be negative 1 over x, I think, right? Yep, negative 1 over x plus b, which is 2x, plus c, which is 0, divided by x squared plus 1. So I'm going to drop the 0. So I get negative 1 over x plus 2x over x squared. So that's my answer. And now I'm going to combine those two again. So to combine them, I have to find a common denominator. So I'm going to multiply by x squared plus 1 divided by x squared plus 1 for the first term. And the second term, I'm going to multiply by x and divide by x. So now I'll have the common denominator. So the denominator is going to be x times x squared plus 1. And the numerator is going to be, got the negative sign, so it's going to be negative 1 times x squared plus 1. And then the second term is 2x squared. So I'll have 2x squared minus 1x squared, which is 1x squared. And then I have negative 1 times 1, which is negative 1. And I divide by x times x squared plus 1. Let's go back to the original equation. You see that's what I've got. So they're equivalent to each other. And then the final one is an example of quadratic factors, repeat quadratic factors. So the first thing you would do is you'd factor it. So you'd have x divided by 4x squared minus 1 times 4x squared plus 1. So you can see that works, because if I multiply these together, I'll get 16x to the fourth. The inner and outer cancel out, and negative 1. But you can actually go a little further with that. You can factor this term into 2x plus 1 and 2x minus 1. The second one you can't factor because they don't have any real zeros for that one. So that's a quadratic factor. Those are two linear factors. Again, 2x times 2x is 4x squared. The inner and outer cancel out because you have plus and minus, and then negative 1 times positive 1 is negative 1. So what we have is repeat linear factors and a quadratic factor. So what you have to do is you have to have a divided by 2x. Actually, no, we don't have repeat linear factors. We got two linear factors. So you'll have a divided by the first linear factor plus b divided by the second linear factor plus cx plus d times the quadratic factor. Now this one you can't do it quite as simply. You have to take the first term and you've got to multiply by 2x minus 1 and by x. And you got to do that in both the numerator and the denominator so that we get the entire factored denominator. Then you have the same thing with b. So you get b over 2x minus 1 times 2x plus 1 divided by 2x plus 1 times x divided by x. So again, I'm multiplying by 1, getting the same denominator. And then the final one, cx plus d over 4x squared plus 1. I just realized I messed up. So we've actually got to multiply by, not by x. I'm thinking of something else. We've got to multiply by 4x squared plus 1 divided by 4x squared plus 1 and do the same thing over here. 4x squared plus 1 divided by 4x squared plus 1. Now we'll have the whole denominator here. And then the last one, I don't have to multiply by 4x squared plus 1, but I do have to multiply by 2x plus 1 over 2x plus 1, and you have to multiply by 2x minus 1 divided by 2x minus 1. Now, we don't really have to worry about the denominator because it's all works out, but what you'll end up doing here is you'll take the numerator on the left-hand side and set that equal to the numerator that I'm going to end up with on the right-hand side, which is going to be a times 2x minus 1 times x to the 4th plus 1 plus b times 2x plus 1 times 4x squared plus 1, and then finally cx plus d times 2x plus 1 times 2x minus 1. Okay, and then you have to multiply all this stuff out. So here we're going to have a times, so we'll use FOIL, we'll have 8x cubed, 4x squared times 2x, minus 4x squared, negative 1 times 4x squared, plus 2x, 1 times 2x, and then negative 1 times positive 1, which is negative 1. Okay, so that's the first one. Then you have b. You get a similar kind of thing here. You're going to have 8x cubed plus 4x squared plus 2x plus 1. And then the last one is going to take 2 steps. You have cx plus d. And what this is when you multiply it together was 4x squared minus 1. Okay. Maybe it'd be better if I just do that over here. So this product here is going to be 4x squared minus 1. Because we factored that out earlier. If you go back here, 4x squared minus 1 is 2x plus 1, 2x minus 1. So I'll use that fact. So now I can multiply this out. So I'll get 4 times c times x cubed, x squared times x. The inner will be plus 4d times x squared. So 4x squared times d. Then I'll have negative cx, negative 1 times cx, and then negative 1 times d. And remember, on the left-hand side, I have x, but what I'm going to do is I'm going to write 0x cubed plus 0x squared plus 0. So you see the zeros in front of the x cubed stuff. So we're going to have one equation involves x cubed, one involves x, one involves x squared, one involves x, one involves constant. So let's, on the left-hand side, we have 0x cubes, and on the right-hand side, we're going to have 8a plus 8b plus 4c. So those are all the x cubed things. I'm just going to check those off. 8a, 8b, 4c. Okay. X squareds, we're going to have 0x squareds on the left, and we're going to have negative 4a, negative 4 times a, and then we'll have plus 4 times b, 4b, and then we're going to have plus 4d. So that takes care of that one, that one, that one. Okay, we do have 1x, so we're going to have 1 here, 1 equals, and so we have 1 is equal to not just 2, but 2a, plus 2b minus c, and then the constant stuff, so let's mark those off, 2a, 2b, negative c, and then the last one, you're going to have 0 constant on the right left-hand side, and you'll have negative a, negative 1 times a, plus b, and then minus d. So this is actually fairly difficult to solve, and I'm going to show you something that you can use your calculator. So if you look at this, we have 0d here, we have d plus 0d, and here we're going to have plus 0c. So we got the coefficients. I'm going to put the coefficients associated with each one of those. So you're going to have 8, 8. So 8 goes with A, 8 goes with B, 4 goes with C, 0 goes with D. In the second equation, you're going to have negative 4 for A, 4 for B, 0 for C, 4 for D. The third one, you're going to have 2 for A, 2 for B, negative 1 for C, 0 for D. And then the last equation, you're going to have negative 1, 1, 0, negative 1. So there's negative 1a plus 1b, 0c, negative 1d. So that's, we're going to call that matrix A. And matrix B is going to be just these coefficients. So it's going to be 0, 0, 1, 0. And what we can say is that the solution to this is going to take the inverse of matrix A times B, and I'll give you a matrix. It'll be a matrix like this, and the numbers that go here are the solutions. So don't worry about knowing the details here, because I'm not going to give you one this tough, but I just wanted to kind of give you an idea of how it would go. So I'm just entering my numbers into my calculator at this point. Okay, so that's 1. And in the second matrix is being entered into my calculator. And then all I have to do in my calculator is do this. So you take A, you raise it to the negative 1 power, and you multiply it by B. And the answers are 1/8, 1/8, negative 1/2, and 0. So constant A is 1/8, constant B is 1/8, constant C is negative 1/2, and constant D is 0. So if we go back to the original equation here, which is this one right down there, so what you get is 1/8 times 1 over 2x plus 1 plus 1/8 times 1 over 2x minus 1 plus minus 1/2 times 4x squared plus 1. And so that is the result. And we're just going to have to trust me that I did it correctly. So they can get kind of complicated.